So in this video, we're going to talk about the alternative definition for a derivative. We've talked about the original definition for a derivative, and this is the one that I memorized for a long time. However, there is another definition that we need to be familiar with as Calculus AB students. Okay, so here goes. The alternative definition of a derivative assumes that we use 2 points, a f of a and x f of x. Okay, and then we limit the distance between the x values by making one of the points approach the other. So let's do it this way. Let's draw a curve. It can kind of look like the same curve that we drew in the previous example if you saw that video. But this time what I'm going to do is I'm going to write a f of a as one of my points, and on the other one I'll write it as x f of x. Okay, so it's still a difference quotient. It's still finding the slope f of x minus f of a over x minus a. Okay, but what we're doing this time is we're saying that x approaches a. Well, if x approaches a, then this point would get infinitely closer to the point a comma f of a. All right? And again, if you wanted to try and approximate what that tangent line might look like, the tangent line might look something like this, right? So anyway, that's the definition, the alternative definition of a derivative. So basically, on the next 2 questions, we are asked to use the definition of derivative, okay, to find the equation of the tangent line. All right, so what we're going to do then is we're going to just find the limit as h approaches 0 of f of x plus h minus f of x all over h. Okay? Now this is the definition that I talked about in the previous video, not in this video. Okay? Since this said just use the definition of derivative, I thought that this was appropriate. Okay, so x plus h, what we'll do then is instead of 5x squared, we're going to write it as 5x plus h squared minus f of x, I'm sorry, the function, 5x squared. And then in the denominator, we could write x plus h minus x, but we're just going to write h, okay? Because x plus h minus x is, they'll cancel out. Okay, so what we'll do then is expand the binomial. If you're having troubles expanding a binomial, just FOIL. There's no shame in that. X squared plus 2xh plus h squared minus 5x squared all over h. And we'll keep going. We're going to distribute that 5 through. Notice that I write this limit part on the left-hand side. Every time I have a line, I need to write that. So 5x squared plus 10xh plus 5h squared minus 5x squared all over h. And what I'm noticing is that I have a couple of quadratic terms that can cancel out. And then, beautiful thing happens, is that I can factor out an h in the numerator. And this feels a lot like the last video. So if you haven't taken a look at that, there is a piece in the last video where I was able to do a step a lot like this, where we took an h out on the top. And what happens is the h's can cancel. And when the h's cancel, I can drop in the 0 for h. And if I drop that 0 in, then it's basically just 10x plus 0. And I just get 10x. So what is 10x? Well, 10x is the derivative. All right, it is the derivative of 5x squared. f prime of x is the derivative of 5x squared. So that's a pretty neat result. Maybe you can find some kind of connection between the answer and the question. All right, so you know what? This one says to use the definition of derivative, but for practice, let's go ahead and try to use the alternative definition of derivative. So this time we're going to say that the limit as x approaches a. And then we're going to do a difference quotient again. This time it'll be f of x minus f of a all over x minus a. So let's try this one. Well, f of x is just the square root function, the square root x. F of a is just square root a. And then the denominator is still going to remain as x minus a. Well, if x approaches a and you substitute that in, you would get 0 over 0, so that'd be indeterminate form. Well, if you get indeterminate form like that, then I guess really we have to either factor or rationalize or find some kind of trig identity. So I guess what we're going to do is rationalize. So I have the limit as x approaches a. I have the square root x minus square root a on top. And I think what I'll do, sorry, there's a little typo there, that should have been an a. And I think what I'll do is I'll multiply by its conjugate, right? So square root x plus square root a. And I'll put that on the denominator and on the numerator. I said that backwards, on the numerator and on the denominator. So when we multiply that out using the difference of squares factoring technique, I know that when I multiply these, I'm just going to get x and minus a. Now, there is no shame in foiling this thing out if you want to foil, but I'm going to use my difference of squares method there. I have x minus a in the denominator. I also have the square root of x plus the square root of a. And what you'll notice is that the factors of x minus a can cancel out and just leave a 1 in the numerator. Now we can drop in this a. So if we substitute in a, I'm getting a 1 over square root a plus square root a, which would be 1 over 2 square roots of a. Okay? And really, this is actually f prime at a. Okay? So I'm sure if I mixed the terms up a little bit, I would have found f prime of x. So f prime of x is just 1 over 2 square root x. Okay? Now that one's a little bit harder to see, the connection between the answer and the problem, but this is indeed the answer to it. All right, I'm going to pause the video. So the reason I paused the video was I wanted to see if we had any more examples, and we do have some more examples on the next page. I'm looking at these examples and I'm thinking to myself, this is going to take a bit longer than I want it to take. So what I'm going to do is shoot yet another video.